Hey guys.
Yeah.
How's it looking with Optiver, Steve?
I think we've only done one update, which was like an update after a month. So
Oh,
I don't think they've made any more. Yeah, because like originally they'd said they were going to do it every 2 weeks, I think, but I don't think that they have. I think they've only done one update so far.
I see.
So I presume the
Is
next
this
one will not be for a few weeks.
wait, is this done like for all the notebooks or like some top percentage? How do they decide?
I think it's for all the notebooks. Like if you look at the
Oh,
leaderboard, yeah, like obviously each person got 2 submissions. So if you look at the leaderboard, it tells you where you are and it tells you how many notebooks ran. So yeah, like I've got 2 notebooks
I
ran
see.
okay. Some people have got one beside them. Yeah, and there's people complaining that their notebooks didn't run at all. So
Oh, something happened. I see. Okay.
yeah, so as is always the way. But
Oh,
yeah, so I'm not sure what will happen like mine. I think it takes a long time to run, and I'd sort of designed it to try and get it to just come in under the 9
under
hours.
this 9 hours. Right. Okay.
With 3 months of data, but yeah, if I've miscalculated, by the time it gets to the 3rd update, it'll just fall over. So.
But I think you made a valid point. Like yours is calculating the time on the API, which they say is much slower than the actual stuff. So fingers crossed. Hopefully it makes it.
Hopefully, yeah. So I have to wait and see.
Are you guys talking about the ensemble notebook that came out later, the earlier this week?
No, Mike, this
Okay,
was the previous competition, the Optiver stock predicting one.
Okay.
Just that notebook. I mean, the submission is done, but they evaluate over 3 months, in which 1 month is over.
Why are they doing that? I
Live
don't.
data,
Okay.
predicting on actual live data to see if that actually works.
Yeah, they've done that on multiple competitions. In fact, the prior one was similar, or I don't know whether it was a big one, but there was a similar one previously that we participated into, which ran 3 months. And actually, it is a pretty interesting way to do it because it actually tests your algorithms with live data rather than just private data. So you can do things like leaderboard probing and that kind of. How are you guys doing in that one, Steve and Rachel?
I'm somewhere in the thousands.
I'm 38, I think. But as
Yeah,
I
I
say,
see, Steve, 38. Nice.
I'm not sure where it'll go from there. Like, if it goes up the next time, that might be okay. If it goes down, then I'm screwed because yeah, it's only going to get worse.
What happened from the previous one? Did you move up or down after the submission?
What, the previous competition?
No, the same one when you actually submitted before this last chunk of live data was used.
I can't remember where I was, and I can't find out. I think it was around about the same position.
Same place, right? Yeah, that's what I thought. Yeah, looks promising.
Yeah, because I think it was in the sort of same position because I hadn't realized that they'd actually put the first sort of private one up because of the fact they put it under the public tab. So I just thought it was the same one because it's, as I say, I was like sort of around there anyway.
Okay.
And it's always interesting to me that sometimes I just seem to luck out, like sitting at 353 with
submissions. Yeah. Yeah, like the other one just finished detecting whether it's written by AI or a student. And there was like a pretty massive shakeup.
How did you enter that?
Yeah, I was there. I mean, I just kind of took part in the beginning, but like I said, there was this initial notebook which was pretty solid. Beating that on the LB was really hard. And I think everyone went, I mean, a good chunk of them went off them. And I think, yeah, there was a big shakeup with that. I see like the top grandmasters kind of fell down, and there were like new people who kind of showed up on top. I haven't actually followed up and looked at solutions, but yeah, that just finished.
Right.
So on this one, I just wanted to mention something that Recollet brought up to me, and then I kind of initiated it. So let me talk to it once I share my screen. So one of the things like I was talking about was, on Slack, things tend to drop off after a while, like, I don't know, 90 days or whatever. And so, he was interested in kind of retaining things over a longer period of time. And I shared with him that I feel guilty about going back. We will have and requesting this, not Discord. Was it this? Is it? It's not Discord. I forget what it's called, but something like Fast AI, where you can kind of post things and it retains it, because Sam and somebody worked for Sam actually attempted to move our Slack over or create another account in that kind of a forum. Fortunately, I was way busy. This was about the time when I went to India, got COVID and a few other things. So I wasn't able to move the Kaggle stuff over. And then by the time I recovered and stuff, things had died down. And so I didn't do it. Anyway, to make a long story short, the intermediate solution that Rekhil and I came up with was maybe we could just capture longer term things that we want to retain from a competition in a Google Drive for now. And then potentially after the competition is over, maybe we can just move GitHub location. So right now I created things here and just put them in, and I shared, I had Rekhil's email, so I shared it. So if you guys are interested in this, then, if you can in Slack, just send me your email. I'll add you to be able to edit this. Then anything generic, this competition, like, things like, hey, here's the reasons to use group K-fold versus stratified. How do you determine when to clip something? This idea of transforming networks in order to be standardized. And then the various couple of different ways that you can standardize data, when to crop images, how to use pre-trained weights with internet turned off, some things, links and efficient net models. And then I think, Rekhil, I assume you added this on what are some of the good models to try from. So if you folks are interested in contributing to this and kind of keeping it going, just send me your email on Slack, and I'll add you to the capability to edit this, and we can just running thing going. And then once the competition ends, we can kind of throw it into GitHub. So that way we kind of continue to maintain or build our knowledge, generic stuff, not, specific things that are really relevant to this competition, but some things that we may want to continue to keep in our memory bank over time. Any thoughts or comments?
Oh, no, that sounds good. Yeah, because as you say, like on Slack, we lose stuff after however long it is, and like at times I've sort of gone back to try and find things and it's gone. So Yeah, putting it all together like this is good.
Yeah. Actually, which kind of led me to, by the way, the thing, just one note. Actually, I did find, I'll locate it somewhere and post it to Slack and potentially edit, but I did find I think the rainforest something sound competition or whatever that actually showed where we use spectrograms from.
Yeah.
For. So I did track it down. It was about, I don't know, maybe 2 years or something. It's very interesting because actually Kaggle even doesn't show me that that's a competition that I participated in previously. So even Kaggle seems to have like a window that it slides. So if I go to, the competitions that here, and if I look at, I mean, yes, these are active, but, even if I look at what of my all the competitions that I have participated in, it doesn't show
Really?
me
Yeah. I'm
that.
pretty sure mine did.
Yeah,
Have you go to all competitions there?
Yeah. Well, this is everything
thought
past and present. Right?
If you go to your profile,
This is
sorry.
everything.
Yeah, if you go to your actual profile.
Oh, okay. Yeah.
Yeah, and your profile, the first menu item there. And then competitions.
And I search competitions, right?
Yeah, so it should be in that list. If you go down. Completed.
Completed, right? Yeah, see, I couldn't find it.
Strange.
Yeah. No, I didn't know why. So I had to go hunting for it.
Yeah.
Because I didn't remember its name, but I found it. I'm certain that we participated in it, or at least made some submissions. I don't know whether, final submissions.
Was it maybe?
I'm assuming we made final.
Was it not maybe one of these competitions where we used to just enter the competition after the competition had finished? Maybe. Yeah, I thought we'd entered into it. Yeah, I thought we'd entered into it as well. But
yeah, I thought it was live, but that's a good point. It may be, but I'm surprised if it was one of those. Anyway, I'll post a link to that, but it's kind of interesting. The other thing I wanted to kind of share, I shouldn't take credit for it. I cheated and, the question that Recollect posted last week of where did those proportions come from? It turns out that the guy who posted the proportions did something weird. But anyway, instead of struggling because I couldn't figure out what was going on there, so I just ended up asking him, and he posted the code saying, "Oh, this is how I did it." And he did something weird, which I'll get into here in a minute. So as he was pointing out, and I kind of, just so I could get it clear in my head, I kind of expanded on Steve's notebook. I started off with what he was doing in his public notebook, but then afterwards, I also wanted to kind of understand each of these proportions and stuff. I kind of calculated every one of them. So I did, this per patient and per patient grouping to figure out what's the code proportions and kind of line by line, so I could fully understand what was going on. But and then you get, if it's the mean vote ratio per patient normalized, then you get this distribution. And of course, the guy mentions that by submitting this to the leaderboard, he gets a score of 1.28 when you do it per patient. And then there is similar things you can do for per spectrogram, which gives you these ratios, and then per EGID, which gives you these ratios. And then the one that Raquel asked, or like, what the hell did this come? And then you can do it, which is what Raquel did online on Steve's suggestion, which is just instead of per EGID, just do it per row, don't group at all, right? And which gives you this proportion. Now that was easy enough, but this wasn't the answer we saw that Raquel had a question about, because that proportion turns out, interestingly enough, this proportion, the guy never submitted to the leaderboard. I haven't done it either, but this is the proportion that, at least so far that I saw, I haven't looked in discussion in great detail, but in these few notebooks that we were looking at, these proportions weren't submitted to the leaderboard so that we get a score to compare how good or bad these are compared to the others. What the guy did was he used this code. And here, if you see the difference between everything that we have done previously, where it was the 6 rows of targets that were being evaluated and summed and stuff. And this is what confused us. And thankfully, I didn't spend too much time because it was kind of a flip of what he did. He flipped it to calculating the expert consensus row, column. So because of that, he gets this proportion. But this proportion is done by, choosing expert consensus rather than doing it. And of course, he does it per row. But if you could do it per row without any grouping, using still 6 targets, but that's not what he does. I don't know why he flipped it, but he flipped it to basing it on the expert consensus, which is what kind of threw a monkey wrench into the non-overlapping, overlapping kind of lingo that confused us. And his proportions are calculated by choosing the expert consensus value. But at least that mystery is cleared up of where he gets these proportions. Any questions on that?
Oh, thanks for asking him out and figuring that. Yeah, that is good to know. Probably make a submission with the other one and see how, what it looks.
I was interested in this one, not this one, EGID, but the ones per row. This one, because to be consistent, he should have actually done this, because you could get, even when you group by EGID or whatever, you could just go by target by expert consensus. But that's not what he does in those cases. In those cases, he goes by the actual target distributions or the target values. But then in this case, he just flipped. I don't know why he did that. But anyway, that's one thing. Second thing, which I think was more something that I was curious about, prompted by Steve's commentary last week. So if you look at, there are 2 approaches to the spectrograms, right? One is using the spectrograms that currently exist, and then the other one, which Chris Diot pioneered, which is to generate the spectrogram from the EEG, right? And but he does it in TensorFlow and so on. And interestingly, I found something which I just pointed out to him, which is irrelevant to Chris, which is irrelevant in the way he uses these, because of the way he uses the spectrogram right now, but his titles are screwed up, and he did acknowledge, yes, the titles are screwed up, because I wasn't 100% sure whether that's what was happening. But anyway, that's an aside. The more interesting thing that I wanted to talk about is this notebook where this guy, I forget, I don't know that I'll be able to, he makes the spectrograms from the EEGs, and I can relate to this better, kind of simplistic, and because his notebooks are in PyTorch, I kind of wanted to follow his path. But one thing that he did in this, when I say this in this notebook, is he creates spectrograms from the EEG. But what he does is he takes the EEG, splits it in the middle, takes the middle 50 seconds. That's why the 10,000, because there are 200 samples per second, and uses that to generate the spectrogram. Okay, so he takes an EEG, and obviously when you take an EEG, the EEG is as wide as its min to the max plus 50 seconds, right? So that's the length of the EEG. And then he takes the midpoint and takes 50 seconds, 25 seconds on either side. So and then converts that portion of the EEG to spectrogram. And of course, he generates the force spectrogram. Everything else is very similar to what this does. But the question I had was, and this was prompted by Steve, because Steve had said, again, if we look at how spectrograms just the Kaggle provider spectrograms were used by this guy in his initial notebook, he was just using the very first spectrogram. And Steve had mentioned, it just commented that, yeah, Steve wanted to kind of use all of the spectrogram rather than just the first. So the question I had in this was, by choosing the middle, is he leaving out any 10-second window? Is he missing any 10-second window from the EEGs that are interesting or that are labeled, right? And so in order to do that, I went back to the notebook that I was doing all these assessments on, and I kind of tried to figure out whether the starting and the ending windows, if you choose the middle of the EEGs, results in missing out any of the interesting ones. And it turns out that the answer is yes. It does result in missing some. And so
what are we calculating here? Sorry, I missed that.
So what I'm calculating here, Pekal, is, let's say you have EEG starting at a minimum point and going to, remember that we have the offset, which is the min and the max offset, right?
Mm-hmm.
And then the length of the EEG is the max offset plus 50, correct?
Basically
max
the middle.
Plus 50 seconds.
Okay, fine. Okay.
Not the middle. The length of the EEG is the max offset plus 50 seconds.
Right, okay.
Right? Now, the way that the guy chooses the portion of the EEG to convert to spectrogram is to choose the middle of this length, and the readings in the middle 50 seconds are converted to a spectrogram.
Right.
But when he does that, the question I had was, are you missing out any of the individual EEG slices that are provided as part of this overall EEG length?
Yeah, okay. So you will be missing out whatever is less. So you should be missing out whatever is less than 50 seconds and whatever is greater than 50. I mean, yeah, less and greater than 50, right? Anything other than that middle?
Yes, but it may not be relevant, because as long as you catch the middle 10 seconds of any 50 seconds window, that's the one that's being classified.
Correct.
Only the middle 10 seconds is what is actually being annotated.
Right.
Middle 10 seconds of any 50-second window of the EEG. but you are given various different offsets.
Right, but they all point
Right.
to the same EEG though, right?
Yes,
The
but they
E-
are different. But they are different midpoints. They are different 10 seconds chunks that they are being labeled.
Okay, okay. I see what you're saying. Okay.
Right. In each, that's why you have the min and the max. Right, because the min and the max, forget the max. The min gives you the starting point from which you have a 50-second offset. The
Right.
middle 10 second of that is what is being labeled for that row.
Right. But I'm saying like
Okay.
if you have the min, basically if you look at the one which has 0 offset, that in essence
Right.
captures all the EEG signal that is there in all the following offsets, right? Like it's the same file that
No.
it's pointing to.
That is true, but that file, the min, goes
Right.
only from 0 to 50.
Okay, I'm a little confused on that.
It goes,
Okay.
okay, let's say this 568657 EGID,
Right.
it has multiple EEGs.
Yeah.
Okay?
Wait,
One
it has only one
EEG
EEG.
which starts, no, not in the original data, this
Yes.
particular EEG ID has
Right.
multiple 50 seconds long data.
Oh, okay, I see.
Because-
Multiple, like if you keep shifting the window, you're saying.
Exactly.
That's what you're saying.
And in
Okay.
fact, that's what each of the rows is. That is what
Right.
each of the rows
Right.
is.
Uh-huh.
Because this min and max are actually different, are on different rows. I've just
Right.
grouped it and put the min and the max through the aggregation. But
Mhm.
this min is 0, and there are various values like 0. For
Yeah,
example,
yeah.
the very first one, as Steve showed in his notebook, had 9 different slices, what I call
Right.
slices.
Mhm.
Okay. So how long is this EEG? The totality of it is 0. I'm keeping it all in seconds, not in, let's not worry about multiplying it by 200 because it's just a constant multiplication, right?
Right.
So if you start at 0 and your max offset is 16, then this EEG has the length. That's what I meant by the length of this slice goes from 0 to 66 seconds. Are you with me so far?
Yeah, yeah.
Right?
Makes sense.
The
Yep.
way, now, keep in mind that 0 to 66, but the very first one, for example, okay, the 10 seconds that we care about in the very first one, which starts at min of 0, goes from 0 to 50. Correct? And
But that
so the
is-
middle 10 seconds of that would be between 20 and 30.
Okay.
Are you with me so
Right.
far?
Right.
The middle of the very first slice, which goes from 0 to 50, will be between 20 and 30.
Correct.
Right?
Yep.
Did you get that?
Mhm.
Okay. The middle of this last slice goes from the start of this slice is at 16, right?
Correct.
And
So
goes, it starts at 16 and goes to 66.
correct. So between of that, yeah, makes sense. Okay, yeah, I get that.
So the middle of that would be at 36.
16 plus
46.
25.
Minus 5, because you have to middle 10 seconds. So that's why I'm adding 20.
41 minus 5. Yeah, right. 36. Yeah. Okay.
The 36, 46 will be the middle of this guy.
Great. Makes sense. Yeah.
Right? My
Yep.
question was, because you're taking a 10-second slice, this is the way that guy slices the EEG to get the corresponding spectrogram. He takes just the middle of this whole thing,
right,
and takes 10 seconds on either side of this. 5 seconds on either side of this,
Correct.
and then creates the spectrogram.
Mm-hmm.
Okay. Then when you do this, my question was, do you miss out any of the middle 10 seconds of your entire slices for each EEG ID?
Mm.
Do
Okay.
you
Okay.
grasp my
Yeah. Yeah.
question?
Right. Okay. Okay. I
Do
see
you
what you're
understand
saying.
the question
Yeah.
that
Yeah.
I'm trying to answer?
Yeah.
Right?
Yeah.
Because if you are, then you're not utilizing all of the data. You're missing out on some of the data from the EEG,
Like,
right?
more
Which
than
is,
missing out, you're not correlating what you're supposed to be looking at versus what is being marked, right? Because
yeah,
you're supposed to be looking at a
yeah,
different 10 seconds altogether. But
yeah,
I had, that's what the same thing was like, because I was looking at each of the target rows, and all of them, I was trying to see what the difference was, and so many of them are so similar. That's why I assume that you need to take the whole chunk of the spectrogram and look at only the middle 10 seconds. But now I see what your question is.
no.
Okay.
No. In fact, Steve pointed out the right thing, which is even in an earlier notebook, when you're forget about EEGs being converted to spectrogram. This is what prompted me, because credit to Steve, because what Steve was saying in an earlier instance, when we just focused on the Kaggle spectrogram, if you go back and look at the notebook that this guy had created, he was just using the very first spectrogram in the list, because he was aggregating it by first, and just using that spectrogram rather than every spectrogram from all of your spectrograms available for a patient. Okay.
Right.
And Steve had already mentioned that, oh, I want to fix this. I want to try and use
But there's a problem with that, right?
rather than just the first.
The problem with that is if you use every spectrogram, your label doesn't change. So you're basically saying, I'm showing you two images of cat, and in one I'm saying it's dog, and the other one I'm saying it's cat, right? So that also is kind of a problem, because the label hasn't changed.
It could be, but I mean, all I'm saying is he just mentioned.
Right. I get that. Yeah.
No, but the label hasn't changed. The label hasn't changed, but it's the same as cat. Yeah, like effectively your spectrogram, all the windows or the slices across the spectrogram, each one of them has the same labels. So it's like taking 6 pictures of cats. It's like your first window, you're saying, here's like a spectrogram and this corresponds to this target. And here's the next window and it corresponds to the same target. So it's like augmentation when you shift.
Okay.
But yeah, like my problem with like the guy's notebook from last week was the fact that he was taking like the average of the targets, but he was just taking the very left hand window, and quite often if you look at the spectrograms on the left hand side, quite often there's like blank areas and stuff. So he's probably better off now taking the middle of the spectrogram, because like that's what Chris Diot does. He takes the middle.
Okay, I see.
Yeah, he takes the middle, whatever corresponding, and he was saying it doesn't change much. But in this case, so what I was trying to figure out by doing the, so all I was trying to do was figure out whether, because he's taking the middle 50 seconds of the entire chunk or length of the EEG, is he missing out on any of the 10 seconds that are interesting from each of the individual slices that make up the full EEG? And so the way I figured that out was to first group it, figure out the min and max. And then obviously there is a start window and there's what I call the end window. That is the ending of the window and a starting of the window, right? So I defined a starting of the window, and I came up with a rule which says, are all my start windows captured or not captured by taking the midpoint, right? And came up with a rule of saying, if this is what is his midpoint, or once figures out the midpoint, which is the midpoint for the first one, for example, is 33, right? Then 33 minus 25 is the start window, correct? So if this rule, which is the start window of his, which is grouped by EEG middle minus 25, is larger than the group by EEG ID minimum plus 20, right? Because the minimum plus 20 will begin the 10 seconds that we are interested in of the very first slice, right? Then I have a problem because his slice is not covering the interesting 10 seconds from a start of the window standpoint. And then I did the same thing on the other side, which is the ending of the window standpoint, which means the ending of the window, his thing is the middle plus 25 is where his window ends. And are there any windows, interesting 10-second windows that lie outside of this from our set of data? Again, if that happens, if this were to be true, then the interesting 10 seconds are lying outside the portion of the EEG that he's taking a slice of. And I did this calculation, came up with this, and figured out, just the Booleans, and sure enough, there were, 3,700 where that is the case, which leads me, at least the result of all this is to say that what Steve was saying earlier is probably should be done even here, which is convert all of the EEGs or each slice to a spectrogram rather than just taking the middle 50 seconds from a 0 to the max plus 50. Right? And use those spectrograms and potentially the Kaggle spectrogram. Does that make sense? Or are there still questions with what I was trying to do? And you can see, this is the reason I printed out these problematic cases. And if you look at the problematic cases, it becomes obvious that, yes, it is indeed the case that by taking the middle point is at 105 and the max point is at 160. And because of that, you can see that by choosing the middle minus 25 on either side, it's not going to cover the very first slices 10 seconds and maybe multiple slices after that. But at a minimum, it does violate the condition that I'm trying to ascertain, which is by choosing the middle 50 seconds, are any interesting 10-second windows lost? And the answer is yes, they are.
So is the solution basically take the min, add whatever the 10,000 rows of 50 seconds for each of the EEGs and then convert that specific chunk?
Yeah, which is essentially saying just take every EEG row that's given, because it gives the min and then individual offset seconds, take each of those 50 seconds and convert it into a spectrogram. Rather than just trying, I don't know why they're trying to minimize the number, because it just generates more data for you. So I don't quite get what's the point of minimizing that by just taking the middle.
Yeah, I think that's just, it's just proof of concept, and it makes sense to kind of not share everything out there, I guess. But yeah, that's a good point that you make. Yeah, okay, I see what you're saying.
So
what's the average length of these spectrograms? Sorry, the EEGs?
50 seconds, so it's 10,000 data points.
Okay, 10,000 cross 50.
50 seconds, each second has 200 readings, so multiply to get 10,000.
Okay.
Right, so that's at least, because before I just kind of used his data that, last week's discussion prompted this question in my mind of, okay, since we have the time, let's do kind of a full analysis. And it's easy enough in this case to, so as you can see here, this is what he does, right? PDD parquet, middle, EG iLock, middle, 10,000. So there's no reason you could convert everything, every row to,
Right.
I mean, you can keep all the rest the same and just generate the data, right?
Yep.
There's
Yep.
no reason why you need to do this MIDI thing. Now, if it were the case that my whatever analysis I did didn't show that you were losing any 10 seconds, then this is good enough.
Right.
Right?
Yeah.
I presume for the targets, though, he averages all of the windows for each EEG. That's what Chris Diot does. Yeah, so like
Yeah, that is something.
Yeah, so
that,
like one single EEG may have like 50 windows, like 50 rows, 50 like different vote things, and like Chris Diot would average all of the votes for a particular EEG and then take the middle section of the spectrogram. Sorry, yeah, for the spectrogram, not EEG. Yeah, so I presume this guy's doing the same. I presume he's averaging all of the things. So
I haven't looked
maybe
at that part yet, but
yeah, so
yes,
like the one
you may
thing to watch
be.
would be if you create like a spectrogram for each EEG window, you just need to watch that you don't sort of imbalance your data set a lot. I'm not sure sort of, yeah, so like it may be, say, one of the categories or whatever may have like lots more windows or something. So yeah, you just need to check that.
Yeah, and that could end up showing poorer results when you did that potentially. And as you said, maybe a good way to preempt that is to check whether the ratio changes if you did it. The ratio for classes changes if you did it this way versus if you. When I say this way, if you did it the way the guy does it by taking the middle versus doing it per EG. So that's a good point. I'll probably make a note of and check. But yeah, so I did you, Steve, do anything with a per spectrogram approach that you were talking about rather than just taking the first test that guy did?
I haven't. I sort of got sidetracked into looking at EEGs by themselves without spectrograms. Yeah, so like one question I had was when Chris Diot does it, yeah, so like the Kaggle spectrograms there are what? They're longer than the EEGs, aren't they?
Yes.
Yeah, so
they
like
are 10 minutes long, so it's 600.
Yeah, so like in Chris Diot's original notebooks, he was taking, was he not looking at the whole 600 spectrogram, the 60, whatever
Yes.
it was, the
And he was taking,
60s.
I think, the middle something. I forget how much of that he was taking. Maybe 50, was it? Or I could be totally wrong and talking from memory.
So what
Can
does he do now? Like obviously, if your EEGs are shorter than your spectrograms, has he sort of cut down the amount of time that he looks at on the spectrogram then to make it all the same?
Yeah, well, that's a good question. I haven't looked into that in his new notebook where he combines. He was talking about, this where he combines the Kaggle spectrograms and the EEG spectrograms, correct? Yeah, I have not looked. Yeah, I have not looked at how he uses the Kaggle spectrograms in this case as compared to the EEG spectrograms. The one tidbit I'll mention, kind of orthogonal to this discussion, is what I did notice as I started my investigation into the way Chris is doing versus the way the other guy, whatever, the Japanese name guy is, or Chinese name person is doing it, is that Chris seems to imply that he uses a single model, trains it on one, saves, and then trains that model, same model. Again, I can't confirm that. I haven't read through his entire notebook to figure out that's exactly what but he says that that's what he does. Whereas the other guy seems to train a model for the Kaggle spectrogram, train a different model, same architecture, but different model for the EEG spectrogram, and then ensembles the results.
Yeah, Chris Diot, he's using the efficient net, and what he's doing, like originally, for the input into the efficient net, he had 4 channels, one channel for each of the 4 different spectrograms you get from Kaggle.
Right.
He's now expanded it. Now he's got his own spectrograms generated from the EEGs. He's increased up to 8 channels, so 4 channels for the 4 areas from Kaggle and 4 channels for the ones he's made himself. So yeah,
Correct.
so that's how he's combining them.
Correct. And in fact, this other guy does it the same way. He
puts them all onto one image, doesn't he?
And that's what so here, if you look into this, what he does is he converts. This is where he's creating from the EEGs to spectrograms. So he creates 4 of them. So that's what this K is. K in the range of 4 and feats of K. So K would be each of these, because each of these is the kind of the 4, whatever those left parasagittal, blah, blah, blah. So those are the 4. And so K in the range of 4. And the XY is the X and Y dimensions of the image. Creates a MEL spectrogram, shoves it into that per K. So now you got 4 channels. And then he averages them. And then along the second axis, he just takes the mean. So he just collapses them into a single thing. And then from that, I assume, and I haven't looked at this, you can just make it, a 3. So you can think of this as kind of like a binary version, if you will. And then you can just do XXX to create a 3-channel input. At some point, I thought even, what's his name, Chris was doing the same thing, that, take the 4, collapse it into one to do XXX, and then give it a the input. So I have to figure out now, are the 2 guys taking different approaches because of what you said of Chris using these 4, retaining the 4 channels from this image, which is the spectrogram created from EEG, and then taking the 4 channels from the Kaggle spectrogram themselves, and then concatenating them in the channel dimension, which is where he gets the 8-channel input into his efficient net.
Yeah, like originally that's how it was. It was like Chris Diop had 1 channel per spectrogram going into efficient net, and this guy here, he produced a single image where he'd like horizontally stacked each spectrogram in the image on top of each other on a single image.
Yeah.
Because in ResNet, it's hard to stick in multiple channels into it. Yeah, so I've sort of taken a different approach. Yeah, my approach is, I've been taking a different approach. Like here, like both of them have been taking the EEGs and playing about with the EEGs to make them into spectrograms. And like when you get the spectrograms, you get 4 spectrograms, 1 for sort of each quadrant of your head.
Correct.
But by doing that, you're sort of like losing fine positioning where the electrodes are in the original EEGs. So yeah, like I've been looking into just taking the EEGs themselves, not making spectrograms, just using the EEG data. Yeah, so like I was looking on papers in code. There's a paper about doing that. So I've been doing that and like looking at EEGs themselves. But I haven't actually produced a
So could you
notebook
send a
yet,
picture?
but like,
Do you end up using it as an image, or is that going into like a cat boost or something? Tabular.
well, the paper's from just recently, and like they use a transformer on it.
Oh, okay.
Yeah, so
are you planning to use a transformer there, or?
well, I was gonna just try and copy
Okay.
what they've done. In theirs though, they're just predicting if the thing is normal or abnormal.
Mm-hmm.
Yeah, so that's the paper. When I looked into their paper, I wanted to see how what they were doing. Like, obviously they've published their code, so their code's up there as well. But what they do, they take their data set, and there's a library called MNE, which is like specifically for like dealing with EEGs. And there's like this course here. Yeah, so I've been going through this course about how to use MNE. Yeah, so like in MNE, what you can do is you can stick the EEG into it, and then I saw like that Chris Diot, he is using like sort of bandpass filters to filter out like high frequency and low frequency stuff to clean up the data a bit. But this course and like the MNE thing lets you do that much more fine grained. And so like because supposedly like in EEGs you get like a lot of noise if you like blink or move your eyes or whatever. So there's like lots of noise in them, which like this software can take out. And and then there's like they use another thing which specifically, what's it called, brain decode it's called, and it just takes these MNE images, and then from that you can like put them straight into a neural network model.
Now, when you say you're using EEGs as is without converting, or are you converting still to spectrogram, or you're not?
No, so not using spectrograms, going straight to EEGs, going straight into a model.
Okay, so and those would be tabular data.
Yeah, well, in that paper that I mentioned, they like tried sort of 4 different approaches or 5 different approaches. Like they tried like sort of like cat boost, they tried like CNNs, and then they tried transformers. So it's basically once you have it in that brain decode thing, or sorry, once you have it in the MNE format, the MNE format is similar to what we have. It's like we have like an EEG, and the EEG has like sort of defined windows along it. So you just stick that into the model, it gives out the windows. Yeah, like effectively just does NumPy arrays or whatever, and then you stick them in the different models. And
But
so,
is
yeah, like
base data that of image or that of series of readings, therefore tables?
Sequence of
well,
data.
Independent of format.
it's the cleaned up data from the EEG. But yeah, so I haven't
And
actually
is
got
the
a
cleaned
model
up
yet.
data
But
still tabular, or is the cleaned up data now in
it's still tabular.
okay.
But yeah.
There was a notebook that combined the different wavelengths or the electrodes, the electrode wavelengths, and they formed a EEG and compared it with the spectrograms. I will share that notebook. I think so. It was shared. I'm not too sure about that, but
Yeah, there's a couple in the Kaggle public thing. that use this MNE. None of them are making any predictions yet, but can you see my screen at the minute? So
Yes.
Yes.
yeah, so this is just sort of like an extension to my original introductory thing. So yeah, like that's just the raw data. Like that, there's Chris Diot's processing on it. Yeah, so like in one EEG, you would have like, yeah, like several like offset windows. Yeah, so as we've seen before, you get like a load of windows on a single EEG, but you can take that on the EEG file, you can stick it straight into the MNE thing. Yeah, so like here, it's reading from the Parquet file and sticking it into MNE, and when you put it into MNE, then you get extra information about it, so you can like label the channels you have. You can see like what filtering's on it. So yeah, like these ones are at 2 hertz. But once you've done that, yeah, so like now this plot here is coming out of MNE rather than NumPy. And you like look at the channels and you can see sort of get some stats about them. But then you can start doing these things. So like here, yeah, like I've defined which, like it's like the standard sort of the layout of the electrons for like the EEG. So once you've done that, so like here, there's like a 3D plot of where they are in your head. So like this is the front, this would be where your eyes are. And yeah, like then it'll give you like plots like this. So like this is all of the electrode channels over 26 seconds of the first of it. But then you can start cleaning like up the EEGs. So here, this is like yeah, like the power spectrum density or whatever. So like supposedly in brains, you're only really interested in from sort of 30 hertz downwards. I suppose you get like a lot of crap as well, like about the 1 hertz or like less than 1 hertz. So you can see here's like a big spike at 60 hertz, which is like the American power frequency or whatever. Yeah, so you can like start adding filters onto it. So here, like this here is like dropping out the higher frequencies above 30. And yeah, like you can like just like clean it up. You can get like down as well. This here is like looking at each of the channels, looking for sort of noise on the channels, which you can clean up. And then you can get like to this, which is like actual images of sort of, you can get like these images from the EEG. So you can see like whereabouts in the head, sort of the high signals are and the low signals are. So supposedly something like this one here, this ICA3, you've got like a big red bit here and a blue bit here. Supposedly like that there represents high voltage here and like low voltage there. And because it's like at the front where your eyes are, supposedly this signal here represents like somebody moving their eyes during the experiment. And like because of that, then you can clean that out of the signal. Yeah, so you can stick it all the way through and you can get like all of these other bits of information. So you can like make the plots like this. So like potentially you could take even this image and stick that into like a CNN or whatever for each line to see like if sort of where the sort of the power spectrum is on your head, where it's like location, like if that sort of matches up with any of the targets. Yeah, so as I say, like that's this MNE library, and then it's used by that brain decode one, which has examples of taking an MNE object and just putting it into a neural network. Yeah, so like I've just been following through like this course here. It's just got like a whole section about EEGs in it, so I've just been working my way through that.
Yeah, that looks super interesting.
Yeah, so like this thing here, this brain decode. Yeah, so like it takes the structures in MNE and then like, yeah, like it's got like loads of examples of just sticking an MNE thing straight into a neural network and like classifying. So yeah, so like rather than going like to sort of taking your raw EEG data and manipulating it and making spectrograms and like losing positional information. Yeah, I was going to try and go straight to the EEG and see how that does.
Cool. So the Parquet seems to have a lot more information than I did not know that was a thing. That was interesting.
Yeah, because the Parquet as well, it's got like information about heart rate in it, which I don't think anybody's used at all yet. So
yeah, the EKG column.
Yeah.
Yeah, and I think all the conversions also don't use the center 3 electrodes currently anywhere.
Oh, did they not? No.
No, as far as I know,
Yeah,
they
no,
only
they
use
don't
the
get used.
yeah.
Yeah, they don't get used in any of the conversions of EEG to spectrograms. I don't know whether, in fact, they get used in your EEG. I mean, the data exists, but the interesting question is, do they get used by any of the outputs during processing?
Oh, that's right. Yeah, I remember now. Yeah, and Chris Diott's thing, it's his banana model, isn't it? So yeah, the bananas go right in the middle.
And in fact, that's where the other thing I pointed out to him, it's not relevant. Currently, the way they are using it isn't relevant, but it could be, become relevant in your, in actually the way you're using EEGs and stuff. Just FYI for those of you maybe switching between Chris's and, doing stuff, but just be aware. So what Chris does, can you folks see my notebook?
Yep.
Okay, so what Chris does, and this is, in this case, the guy has commented it out, but what Chris does is he has the names, right? And he then also pointed out that his naming was incorrect, but he has these names, LL, LP, RP, RR. And if you go back and look at his notebook where he generates this, from which this guy has copied it, and so the names don't align. Unfortunately, the last two don't align with the nodes that he's put it. They are flipped, which is what I pointed out to him. So because of the way that it's all being collapsed, which we already discussed, like, the four are being collapsed one way or the other way, but either way, in both cases, they are being collapsed. So it doesn't really matter. But if you were to use them individually for whatever reason, then you need to be careful because he has kind of flipped them. So if you go back and look at the banana picture, then what you'll see is that, these are flipped in his notebook, which I pointed out to him. If you go see the comments from where he has the original, generation of how to make spectrograms from EEG, right? So let's see, banana. Yeah, here's the banana picture, right? So, this is LL, which is the red one, and then the corresponding will be LP, and then he see the RP, right, which he calls the right parasagittal, which is this green guy. So you can see that the green guy should be FP2, F4, C4, P4O2, but that's not what is the third row or whatever this at the third index. It's actually FP2, F8, which is this guy. So the naming, and then by the way, he calls this RR, which he also says is later. So if you look at the comments, so this is the point where I pointed out to him that, his names and your feature lists are kind of stood up, and he does say, yeah, that's, and also the names should be different. It should be actually this RL, RP rather, and then he's, instead he calls it RPRR. So that's another anyway, be careful of this because this can trip you up if you're kind of going back and forth between anything he does and like using the EEG data as Steve is doing. I was going through that, I noticed.
Yeah, so I haven't figured out what Chris Diott's doing that's better than his public notebook, because the score he has on the leaderboard's much better than his notebook gives. Any idea what he's done to change it?
I was just thinking of, there are at least two simplistic things that I was thinking of, Steve, two simple things. And I don't know whether they would account for all of the things, but at least on my list of things to try were those two. One is just, I know from the rainforest competition that certain augmentations helped improve the spectrogram waveforms significantly that people are using. So I wanted to that's why I was interested in figuring out what kind of augmentations were used in that case. And while I'm at it, I'll also mention that especially kind of piggybacking off of your comment about, this low frequency ranges are what matters. I wanted to go back to the kind of like the audio course, and maybe instead I'll spend my time with this neural course to figure out what enhancement, besides the augmentation, once you have it converted to spectrogram space, what improvements you can make even in the conversion process or of converting the EEG, because your focus is on the low frequencies, and anything in the high frequency or anything like the 60 hertz noise from the power supply and things like that, what you can do. He has a low pass filter, but are there more things you can do there to improve your waveform? The augmentation of the spectrogram. And the third thing, I definitely saw somebody comment, and it potentially is part of what Ricky pointed out about using better computer vision tools, including, for example, I suddenly forgot, not cut mix, but mix up, I think. Where you kind of slice the spectrogram image up and use that to confuse the network and get it to better generalize. Those are the simplistic steps that I was thinking I would add on to the basic notebook that he has. But I don't know whether doing those three things would get you to where he's at. But those are the three things that I thought of and listed down.
There is an ensemble, I think, which pushes you to like 3.9, which I just submitted, I think, yesterday or something. And that was basically using
that's the one.
A ResNet.
Yeah,
using a ResNet and an efficient net. And surprisingly enough, I thought a simplistic thing to boost the score would be changing B0 to B2, but I got the exact same score, so that didn't really help.
B2 is actually, he claims B0, but he actually uses B2. If you look into
Really? No, he uses B0.
Chris is using a B2.
He started using
but
B2.
in the notebook it's B2.
No, he started using B2, and then when he brought in his own spectrograms, he went to B0.
B0,
yeah.
It's for speed, exactly.
I've actually trained B0, B1, and B2.
Mm-hmm.
As you say, B0 and B2 pretty similar. B1 gave me a slight improvement.
I see. Okay. So that was the I don't know, like
his last notebook, if I'm not mistaken, it still says B0 starter, but I thought I saw that it was a B2.
No, it says B0 there.
Oh, no, it's a B0. Yeah.
Previous version, he was using a B2, like Steve said, but and I've been trying
using a B2 with this. Were you using with this notebook or with the other guys
No, this same thing. I was just using a B2 instead of a B0, and yeah, it didn't. I mean, I submitted to leaderboard, and it made absolutely no difference to my score.
Okay, I see. Okay.
The only other things that I have been trying was the usual CV approaches of freezing, fine-tuning, and that kind of stuff. Haven't made any submissions on that. My CV doesn't seem to improve, so I didn't kind of go ahead and submit anything. Got sidetracked with the WaveNet approach, and I've been kind of trying to understand the WaveNet and how to use the EEGs out of it. For some reason, like I posted that question on our Slack, why the signals that he's using for the WaveNet are being used, and I don't seem to have. I saw what you posted, Mayank, but I don't see any explanation as to why he's using those. And I think the one you posted is more of converting an EEG to a spectrogram rather than using the WaveNet starter. He's using, if I shall, do you want to open that notebook up, Srinivas, or do you want me to share my screen? Either thing works for me.
Oh, I'll stop sharing.
Give me 1 second.
I'll obviously post this chat, but if you can send me your email, I'll add you to the, if you share your email to me on like personally, then I'll kind of add you and you can put those things onto the Google Drive as well. A couple of sentences on what each of those links are.
Oh, yeah, so this is the WaveNet one, and yeah, here he talks about just using these two features, and again, I think that's more like POC. Then he kind of, this is the update. This is the new kind of architecture that he uses to combine things up. And if you look at, this is where, so this is that FP1, T3, T301. So if you look at what that corresponds to is you basically end up using FP1, T301, FP1, C301. And same thing on this head mirror image. So there's a lot of electrodes which are not being used. And yeah, I don't know how to combine them or what the intuition behind combining them is.
Do you have to do a combination of them? Like,
So you're saying pass them in as individual signals?
Yeah, could you just turn each EEG from like each electrode into its own spectrogram and make however, what, 20 spectrograms and put 20 spectrograms in?
Don't think will work, because if you look at this one where he talks about how he's made these spectrograms, there he specifically mentions, if I can find that, is, give me 1 second.
Yeah, because I thought he was trying to make his spectrograms to match up with the Kaggle ones. So as he had like found out how Kaggle had made theirs, but yeah, I wasn't sure. Is it possible to make one per EEG channel?
Interesting.
Or does it matter, but the difference between?
I see. So you're saying, okay, because he was trying to match it up with what Kaggle has, and that's why that was the approach he was taking. But I think, like, if I remember what I saw in the comments, and someone was pointing to some other resources where they were talking about how you need to take the differences. Where is it? Give me 1 second. Let's see if I can.
Yeah, basically, he had put the equation initially, which is, the first one minus the second one plus the second one minus the third one. And then somebody pointed out that if you just did that, then you could just take the first and the last and everything in between dropped out. And then somebody said, no, you can't do that because you have to take the potential difference and,
Right.
Yeah. Basically, when you take the spectrograms, you kind of lose the phase if you do like an average all throughout. So that's why when you take the spectrogram of each of them and then kind of take the average, it kind of brings the phase back in. So you make a good point, but yeah, I don't know, like if that is something that is worth trying. Yeah. maybe, I don't know how you would go about converting. So you're saying each waveform, you basically try to convert that out and then see what you get from
Yeah,
there.
but I don't know
Interesting.
enough about spectrum. But yeah, like it is maybe, as like Srinivas says, it's maybe sort of the difference between two, because it's, yeah, like whatever signal is happening inside your head, it permeates its way to the electrode on your scalp. And it is maybe sort of the difference in this when the signals arrive, as opposed to just whatever like a signal electrodes picked up.
So yeah, I'm not sure what that is, but yeah, other than that, the WaveNet one, yeah. So the other thing that I was curious about was like you mentioned, like the EKG and then the other three electrodes which are just not being touched. If I could feed that in somewhere, maybe, I don't know, along with the CNN towards the end, like get the features out of the CNN and then combine these features somehow and then kind of train on that. That was something I was thinking of. But yeah, I haven't got into that yet. But yep, that's pretty much all that I have tried. Oh, and then there was someone else who was trying to use other transforms. I haven't gotten time to look at this notebook, but yeah, it seems interesting about other short forms, short time Fourier transforms, and continuous wavelet transforms and stuff like that. So I don't know if there is some other form of signal that is kind of getting captured there that could be helpful for the CNN. But I think he says he made submissions and it didn't help somewhere. I think I read that, but yeah, like Steve, your approach seems like very interesting. So yeah, keeping the positional information and stuff like that. Yeah, I'm curious to check out that course and see what their approach is.
Yeah, no, the course is good.
Mhm.
But yeah, like it's going into like, yeah, like using low pass and high pass filters and like cleaning all the data and stuff. Whether there's enough time and when you're actually sort of like at inference time, if you can like, is there enough time to go through them all and do that? I'm not sure.
Do that stuff, yeah. Interesting.
But at the end of it, you're saying, yeah, what I would be curious about, which might be interesting thing also to try, is do the cleaning up, get the table, then convert it into spectrogram and see whether that gives a better result.
Yeah, so Christy, as we said, like he does apply like a low pass filter, I think, on it. But yeah, so like it might be worth using his approach, but like putting it through like this cleaning mechanism first to take out other bits and pieces and then make the spectrograms and try that.
Right, first clean, then use the clean data to generate, use your method to clean, then use the clean data to go to a spectrogram from EEG, and then combine.
Yeah, so like do just what Chris Diot has done, but yeah, like use cleaned up EEGs before you make the spectrograms.
Right. That could be very interesting, because that was one of the things that I was saying I wanted to do. But in the spectrogram, in the conversion process, and that's precisely what you're pointing to. This thing does probably better than just a low pass filter applied. So it's kind of doing cleaning while being aware of the kind of data that you're handling. Just, a better cleaning process, because you're sensitive to the nature of the EEG data while you clean, whereas some of these low pass and those type of things would be broad, generic, just cleaning frequencies, but this could be cleaning EEG frequencies.
Yeah, as I say, like in that course, it says like you can get like lots of noise just from people moving during the experiment, and people blinking their eyes or moving their eyes, and it says you can filter out all of that stuff.
Yeah, that'd be excellent. Yeah, because those kind of things you're not catching by just doing a low pass, I believe.
Although if somebody's got a brain problem, maybe they might blink a lot, and then if you clean that out, you'll miss it. If they're having a seizure, they might be blinking.
Yeah, good point. Yeah.
So that might be a
I think
signal.
his was completely heuristic in the sense that he was saying, I think in a post he's mentioned, right, like all the Kaggle spectrograms have like a maximum frequency of 20 hertz. So that's what he was using to filter.
Right.
Anything above 20 was getting chopped off. But yeah, I mean, but from the quick glance through of your notebook, I think like there was somewhere where it mentioned like min frequency, max frequency, and that was like at 100 hertz or something, which is, yeah, interesting that we need to look at that and then see how you would use that to filter stuff.
Yeah, well, the data is sampled at 200 hertz.
Mm-hmm.
So like that's maybe what it was. But yeah, like I've just been following through that course and you know, like using like this competition data just to follow through. But like yeah, like they chop off below 0.5 hertz and then they chop off above 30 hertz, I think it was. I think yeah, like in
Okay.
there, I think it says yeah, like anything less than sort of 30 hertz or whatever isn't a relative brain.
Okay.
A relevant
Okay.
brain signal or whatever. So I think I chopped at that point.
30-20 kind of in the range, right? So it seems consistent that
Yeah.
they wouldn't, that even our spectrograms don't give anything above 20 because probably it isn't relevant. And yeah, so the and the 100 seems when your sampling rate is, you know, like if I can recall the Nyquist, you need to do 2x of the minimum frequency that you're interested in. So, you know, if just with a double the margin and then 2x, so something like if 30 is what you're interested in, double it, get to 60, but okay, round it to 100 and then you sample it x. So there's no way that by sampling at 200 you're missing out anything. And then you then obviously can break it down to only worrying about bottom 30 hertz or 20 hertz.
So, Steve, are you going to publish this notebook with the course that you were trying to make?
Well, I haven't yet because I haven't sort of worked all the way through the course. I might do, but I'm not sure yet. So,
Okay.
as I say, like all I've done is there's one particular chapter in that course that I put up the link to, just about EEGs. So I've just been working my way through that with this data. But yeah, so it may go nowhere. It depends on processing time and stuff. Like I may not even have enough computing power to be able to like do this.
Okay. So is there some separate amount of compute required? It is just I think so the Parquet files that are there.
Yeah, so you need to take the Parquet files and like for each EEG, stick it into the MNE thing and then run the cleanup stuff. So yeah, like I'd tried it quickly and like had run out of memory.
Okay.
But yeah, there's probably a way to get around it. Yeah, like then it would like generate a data set from it, but I haven't done that yet. But as I say, there's a few notebooks up there already. There's a couple of notebooks if you just like search for MNE within the Kaggle public notebooks. There's a couple. Yeah, it just gives you sort of nicer pictures of like where the spectrograms are, or sorry, where the EEGs are in your head and where the signals are and stuff. So it just gives you nice pictures of heads with red and blue waves on them.
Mm-hmm. Yeah, that makes it easier to visualize and see what is being applied where.
I had a slightly different question to the top on this topic, which is, you know, we have these targets in the various fractions and stuff, right, for the 6 classes. But interestingly, there is also the consensus. Seen anybody use the originally what I saw was, you know, I think maybe in the very first Christie notebook or whatever, apparently I saw him use just the targets as the target. Sorry, the expert consensus as the target, but then he very quickly moved away from it, right? Because ultimately you want to wanted to see whether anybody has continued to use the target, the expert consensus column. Now, one disadvantage of that is that's obviously not available in your test data. So I was just curious.
Yeah, that's the output that we want to find out, right?
Not really, right? Because it's the targets, individual targets, proportion or fraction or prediction, not the expert consensus.
Okay,
So
okay.
the consensus looks across all of it and says, oh, but I think it's just this. But what we are after is the fractions of each of the 6 classes.
Mm-hmm.
Think the test.
Yeah, I think in the dataset description also just provides that. It's provided for convenience only.
Yeah.
So it's not something you're predicting, or I don't know, like maybe you can use that for something like an auxiliary loss that you want to kind of improve the model. I don't know, but this is a much harder problem than predicting just the expert consensus. So I don't know, it's kind of hard for me to justify why.
The other interesting comment I saw, relevant, I thought, to this cat dog discussion that you were just mentioning, is the fact that apparently, and I haven't, again, dived into the data and looked at where this is the case, but I saw Chris, I think, comment in one of the comments thing that the class changes over time.
Oh yeah, correct. Towards the beginning or towards the end of the, yeah, I remember seeing something about that. Yeah.
Right.
Yeah.
So, but again, it's not. That's where I was focused on the middle 10 seconds kind of thing, because the class doesn't change. It changes in a EEG file or in a spectrogram over time, but it doesn't change over the 10-second window. For a 10-second window, it's fixed.
Oh, you're saying if we look at consecutive rows, but how, like only one row you can look at this 10 seconds, right? How else, how are you making that
that's why I'm saying for that 10 second, it doesn't change. But his point is that if you look at an
as the offsets, right,
or a spectrogram, then per offset, which means per 10-second window in the middle, it could change.
Right.
So that shouldn't matter as long as you drill down on the middle 10 seconds, right? Because that middle 10 seconds, for every middle 10 seconds, there is a particular distribution of classes. That doesn't change.
Right. Yes, I think this is more of getting more data rather than data augmentation, right? Because your label itself is changing.
I wanted to get, which is why, while being sensitive to what Steve said about, does it change the proportion? But, setting that aside for a minute, this is why I was thinking that his original comment last week of, just taking the, of course, you have to adjust the target to make sure that your targets are appropriately chosen, right? That I mean, that you don't average a target and then, you do something on the other side. But like, if you can choose per EEG and per spectrogram slice, then you're better off because you're just generating more data. And I've been puzzled because given that you can store all of that data as an NumPy file and then as a single, entity and then just go get it, like Chris showed, as to why you wouldn't do that and why you would collapse some of the data if you're missing some 10-second windows in that. It's what prompted my, whole investigation. So it just seems like at least, it's better. You're better off generating all of the slices, at least from the EEGs. If you're going the EEG to spectrogram route, you're better off generating all the spectrograms from every slice of EEG, subject to cleaning and all that stuff.
Yep.
The good thing is, starting early gives you the time to explore, like Steve is doing with his stuff. And I've been like really trying to get more by doing all this stuff, getting more familiar with the data. The more you play with it, the more you can kind of intuitively understand the layout of the data.
Yeah, I totally agree. The more you have done EDA with it, the more you understand it, the more you practice with it, the more you will be able to get the insights of it. What was the deduplication thing that you guys were discussing on the Slack?
Yeah, no, I was just commenting on the kind of frustration I had personally with the non-overlapping comment, which the word overlapping doesn't make sense in the way they're using it. He, like I just showed at the beginning of what we talked about, what he calls non-overlapping is just all of the rows. So think of it as non-overlapping, meaning no grouping. And grouping to me, just so as not to overload the grouping term, I was just saying deduplifying is a better word than overlapping, because deduplifying EGs means that you have one EG, or deduplifying spectrogram means that there's a single spectrogram choice that you make, which is the same as grouping by EG or the grouping by spectrogram. But by doing that, you're not eliminating overlap, because a single spectrogram, as we have discussed, or a single EG has overlapping data point, overlapping slices, because there are multiple slices within a single spectrogram and multiple, slices within a single EG. If you go from min to max, you group by EG, you group by EG, a single EG still has min to max, and the entire thing is there in a single EG grouping, and that still has what I refer to as slices, 50-second slices, but multiple of them, and those are overlapping. So that's why this whole terminology of overlapping, non-overlapping confused the hell out of me. But I think that aside, we now know how the guy figured out the distributions that he was looking.
Yeah.
Puzzle.
Specifically the overlaps, the slides, the 60, the length that you initially alluded to.
Before we wrap up, I have a Kaggle question actually. So how are you guys submitting the notebook? Because last time when I was saying that I used the submit button, you guys were saying you do something different, right? I was just curious, what was your process?
I save the notebook and then go to the notebook output and click on the submission.csv file, and the submit button comes up.
I see. So when you say you save the file, is it that right-hand save version, then run everything, or is it the file save? Which one? Let me. Should I share my screen?
Yeah, if you can share your screen.
Okay, I'll make this easier. Okay, so let's say this notebook.
Yeah, so there I would go to the top right-hand corner to where it says save.
Okay. And
click on
save.
that, and then save it. And when it
okay.
Yeah, so like that's a standard save with run all. So when that finishes, yeah, so if you go to a notebook now that you have saved, that you've saved already, just go to your code or whatever.
For this
On
one?
the left hand. Well, go to the left hand side. You see the less than greater than icon.
Okay.
Yeah, that one. Yeah, go to your work. If you pick one of your notebooks that's got an output.
Okay, and then go to, okay,
Yeah.
I see.
Yeah, and then you see that submit button.
Then
That's
hit
where
that
I
submit.
submit from.
I
Yeah.
see. Okay, cool. Yeah, I've been
Yeah, that's what
burning
I
through
do.
a few more like GPU minutes. I was just wondering, maybe this is a better approach. I should try this.
How else can you submit?
That's what
I just finished executing. I mean, running whatever I have to run here.
Yeah.
You can submit through CLI as well if you
I'm ready
process
to
everything on your computer.
submit. And I just hit this.
you're breaking up, Rick.
Button here.
Sorry, I can't hear.
You're breaking up.
Sorry.
I
You're
couldn't
breaking
hear you
up,
there.
so we couldn't hear you.
Sorry, can you hear me now?
I think
Yeah.
so. I wasn't sure what Manny said either.
You guys hear me?
Sort of.
Can you hear me now?
Yeah.
Yes.
Can you hear me now?
Yep.
Sorry,
Yes.
I don't know what happened. So yeah, like I was saying, so I just so the submit button here. So I just
All
use
right.
that submit, and then it reruns this notebook the first time because it makes the notebook submission. Then it runs the conversion to script, and then finally does that submission. So I kind of rerun this file again. Until and unless, like last time, what we spoke about using those Kaggle flags of how to force jump out of stuff.
Oh yeah, so you'll be losing GPU time when you save it, and you'll be losing GPU time when you submit it.
Yeah.
Yep.
Bottom one, so ensure everything is good. And then if I hit this submit, then I unnecessarily have to rerun that again before it actually makes the submission. But the way you guys are doing it, by doing save like that, that is just using your as ones, which makes sense. And
Rekli, you're breaking up. We cannot hear you.
it doesn't.
I need to drop off here anyway, guys, so I'll have to head
I
on.
should start doing that.
Okay. Thanks, everybody.
So yeah.
See you all next week, and hopefully we'll have a few more submissions and a few more questions to discuss and so on. Thanks everyone for joining.
Okay, cheers. See you next week. Bye.
See you all next week.
Thanks, guys. Take care.